So when I say opposite, we're talking, well, actually, let's start with hypotenuse. Put a star next to this because usually we want to do this first. I'm actually going to write do first here, and I need to change my notes, so it's actually first. You guys have heard the word hypotenuse before. In terms of the lengths of the sides, what's special about the hypotenuse of a triangle? Is it the shortest? Is it the longest? Is it the medium-sized one? Hypotenuse is always the longest side. And when I look at it in relation to the 90-degree angle, where is the hypotenuse in relation to the 90-degree angle? It's always across from the 90-degree angle. It's the side across from the 90-degree angle. So in this first triangle down here, go ahead and draw that little box in there for a 90-degree angle. And let's label our hypotenuse. And I'm just going to abbreviate these with the first three letters, HYP. I recommend that you, when you're labeling a triangle, which is always going to be step one for trig problems, when you're labeling a triangle, do the hypotenuse first. Your other two sides are going to be your opposite and adjacent. We'll abbreviate those as well. Now, these can get tricky, and this is usually where people make mistakes when they make mistakes in trig. When you do this, you're always going to be looking at some reference angle. So in this first triangle here, this is the angle that I'm going to use as my reference angle. And I like to picture like an eyeball looking into the angle right there. And if you think about that eyeball looking into the triangle, the side that it's looking at, the side that's directly across from it, is going to be your opposite. So it's the side or leg that's across from it. Side that's across from your angle. So if my reference angle is here, I'm looking into my triangle, and the side that's across from me, what I'm going to be seeing is going to be this one. I would label this the opposite side. And then the adjacent side is going to be the side that's next to. Adjacent means next to or touching. So again, if my eyeball is here and I'm looking into my triangle right here, my adjacent side would be right here, because it's right next to my eyeball. Anybody want to guess why I encourage always labeling the hypotenuse first? Why do you think? It is the easiest. That's one of the reasons. It's the easiest, and you're used to doing it already. Why else do you think? So I don't mess it up with the adjacent, because adjacent means next to, right? Isn't the hypotenuse also right next to my eyeball right here too? It is, but the hypotenuse will never be your adjacent side. Adjacent is technically the adjacent leg, the leg that's next to it, and the leg is never an hypotenuse. So always do your hypotenuse first, so you're not tempted to call this the adjacent instead. Okay. All right. So can I get you guys with these remaining three triangles to first label your hypotenuse, and then focus your attention on this reference angle. Label your opposite and adjacent on those three triangles as well. Hypotenuse and then opposite and adjacent. Make sure you draw that 90-degree angle in there. That's going to help you find your hypotenuse, because the hypotenuse is always going to be right across from that. And then your hypotenuse is going to be a little trick. See how this is my angle? I have turned it around so you're facing into the triangle. So you might be looking at this. Which is the side that you're looking directly at? Which one's across? Label that one opposite, and this one could be adjacent if it's next. Oh, I see a couple of you doing the trick. Nice. I didn't even show you the trick, and I saw a couple of people doing it. So I always have a couple students that'll figure this out, and that's awesome. But several of you already have. Sometimes my students will actually spin the paper around. So like if I were looking at this one, I might spin it so that when I'm looking into the triangle, like my eyeball is actually looking into it from this angle. And that helps me to see that this is the side that's across from me. So this would be my opposite. I'm writing upside down here. And this would be my adjacent here. So sometimes actually rotating your paper around so that you're physically looking into the triangle from the right spot helps you to see this. So let me go ahead and label the rest of mine and catch up to you guys. You can check yours against mine, see if I've made any mistakes here. All right. How are we feeling about opposite, adjacent, and hypotenuse at this point? Can you guys show me on your own thumb meters where we feeling right now? I'm feeling like, yeah, I'm kind of there. Or I could ace the test on this right now. Oh, okay, that's a lot of confidence. That's good. Does anybody have any questions before we move on? Doing all right? Question, go ahead. Oh, that's a great question. We're going to get to that in just a second. So just a little patience, please. Any other questions? All right. So step one is always going to be to label your site. So you guys have already mastered the first step of solving a trick problem. The second step is where we're going to stop today. I'm going to show you how to do the second step. We're not going to talk about the third and fourth just yet. Okay, the second step is a little bit trickier. Okay, so I want you guys to give me your full attention when we do this. And I'm going to tell you that in the second step, we're going to be writing an equation. And our equation's always going to have the same format. So like I said, one of the great things about trigonometry, one of the things that my students like about it, is that it's pretty consistent. In the second step, we're going to write an equation, and the equation will have the format that's going to look something like this. It's going to have something here. I'll tell you about what those are in a second. You don't have to write this down. I'm just kind of giving you a preview. And it's going to have some angle here inside of parentheses, and then an equal sign. And there's going to be a fraction over here. And on the top and bottom of this fraction, you're going to have some sides. Okay. So there's kind of three different things that could go into this little box right here. And those three things are called sine and cosine and tangent. I'm going to write those down right here. Sine and cosine and tangent. And when we write equations and when we put these into our calculator, we actually only use the first three letters, sine, cos, and tan. And that may be familiar to many of you because you've been looking at those three things on buttons on your calculator, right? I asked you at the beginning of the year to get a scientific calculator. And if you notice that sin, cos, and tan on there, that's what you're dealing with, sine, cosine, and tangent. Okay, so what's going to go here is going to be a sine, a cosine, or a tangent. Angle's always going to go here, and then two of your sides are going to go into the fraction, and it depends which side you're going to do is going to depend on whether you're dealing with sine, cosine, or tangent. So this is kind of the key here for how you write these equations. It's a bit of a cheat code, and we'll come back to it in a second. So what I need you to know is that when we write an equation with sine and we create our fraction, the fraction part of our equation, it will always have the opposite and the hypotenuse. In fact, what it's going to look like is sin of our angle is equal to, it'll be opposite on the top and hypotenuse on the bottom. Always, 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 if we write an equation with sine in it, our angle is going to go here. We're going to have opposite side on the top, hypotenuse on the bottom. Always. Cosine will look different. Anybody want to guess what two sides we're going to use for cosine? What do you think? Adjacent to hypotenuse. That would follow. So when we write a cosine equation, we'll say COS. Always your angle. But this time it'll say adjacent over hypotenuse. Which two sides do you think we're going to use when we write a tangent equation? Opposite and adjacent. So a tangent equation, again, it's always the angle that comes after it. And the fraction will always be opposite on the top and adjacent on the bottom. And that is the key. So I need you to know that when we write a sine equation, sine goes with opposite over hypotenuse. Cosine goes with adjacent over hypotenuse. Tangent goes with the opposite over adjacent. And you've got to memorize that. I'm sorry. What do you mean? Oh, okay. And that's a lot to memorize. So how are you going to memorize that? Excuse me. Well, that's what this is up here for. So this is called a mnemonic. Have you ever heard of a mnemonic before? A mnemonic device is something that helps you memorize something. It has no meaning on its own, but it helps you to memorize it. So I want you to say this a couple times in your head. So ka toa. So ka toa. So ka toa. Say it out loud. So ka toa. Go ahead. Say it out loud. So ka toa. This is really awkward. I'm the only one saying it. So ka toa. So ka toa. So ka toa. When you get to a test or a quiz over trigonometry, the first thing you're going to write, after your name, first thing you're going to write at the top of your page is so ka toa. Because this is your key right here. If you can remember so ka toa, that helps you remember that sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Okay, this doesn't mean anything, but it's a key. It's kind of our cheat code to help us remember which two sides go with sine, which two sides go with cosine, and which two sides go with tangent. Okay. All right. So we're going to move down the page here, and I'm going to simplify this a little bit because I think this is a little bit tougher than we need it to be. Can you guys cross out this y up here? And same thing with this b over here. We don't need those for right now. We'll come back to that later. In fact, let's cross out this whole column with the y's and b's here as well. All right, so we're going to practice writing equations. All right, notice that the sine, cosine, and tangent here all have x after them because x is the angle, right? And the angle is the thing that always comes right after the sine, cosine, or tangent. Okay, so I've already taken care of that. All you need to do is write me a fraction with some numbers in it over here. Now, before we do that, we got to do a little bit of work first. Step one is always label your sides. So go ahead and draw your 90-degree angle in here, and then please practice labeling your hypotenuse and your opposite and your adjacent for this first triangle. This is from the point of view of the x here. So your hypotenuse and your opposites and your adjacent. Check over mine, make sure I did that right. Question? Yeah, bring me a note back. Thank you. Any questions about that? Are we good with hypotenuse, opposite, and adjacent? Question?
If we label our like opposite and adjacent as that right hand like a leg foot would be marked as standpoints. Show that.
A leg and a foot. Yeah. Why don't we give it a shot and see how it goes? What's more important to me is, can you get the right numbers in the right place here? So why don't you give it a try and see how it works? So the question was, can we use something other than opposite and adjacent? If I ask you on a test, what is the opposite side, and you'd be able to tell me though that the opposite side is 8 though. Can you do that even though you're using leg and foot for it? Okay, then yeah, I don't have a problem with that. No, but if I ask you specifically, what's the length of the adjacent side, would you be able to tell me 15? Awesome, then that's fine. All right, so we need to now put these numbers into our sine, cosine, or tangent. I'm going to go ahead and write this up here. Go ahead and write it right now. You might be thinking, why do I need to write this? Because it's right above there. I'm going to tell you that you're going to probably end up writing SOHCAHTOA down at least 50 times this year. Every time you do an assignment, you're going to be writing SOHCAHTOA down, if you're smart. All right, sine. We're going to be looking at the SO part of SOHCAHTOA, and it tells us what goes on the top, what goes on the bottom. First thing goes on the top, second on the bottom, opposite on the top, hypotenuse on the bottom. So I'm going to make a note here that I'm looking for opposite and hypotenuse, but then I'm going to go to my picture and write down the actual numbers. The opposite was the 8, that goes on the top. The hypotenuse was the 17, that goes on the bottom. And I've completed that equation. The sine of x equals 8 over 17. That's our first trig equation. Let's see if we can complete a couple more. Cosine. This time I'm looking at this part of SOHCAHTOA. Cosine has adjacent on the top and hypotenuse on the bottom. So adjacent on the top. Which side is my adjacent? How long is the adjacent? 15. So 15 on the top. How long is the hypotenuse? 17. So 17 on the bottom. The cosine of x equals 15 over 17. This last one is tangent. Tangent goes with which two sides? It goes with opposite and adjacent. We want opposite on the top, adjacent on the bottom. So find me the numbers for opposite and adjacent and put them on the top and bottom here. Opposite on the top, adjacent on the bottom. So the tangent of x equals 8 over 15. Question? Yes, absolutely. So if we were doing this second set of angles, the question was, would we just have to flip the opposite and adjacent? And the answer is yes. Why would the hypotenuse not change? Because the hypotenuse is always the hypotenuse. But we would be looking from a different part of the angle, so we would have to flip our opposite and adjacent, which means these fractions would be a little bit different over here. We're going to get into that later on, though. So that's why I said let's kind of keep things simple for you. Question? Yeah, that's another great question. I would like you to simplify the fractions if you can. Right now, my main thing is, can you at least get the right numbers from here into the fraction? But if you can simplify the fractions, it's always a good idea to do that. Excellent question. Thank you both for those questions. Can I get you guys to go ahead and try this next set here? Please start by drawing your 90-degree angle and labeling your sides. We always want to label our sides first. Go ahead and label your sides first. And then go ahead and use your SOHCAHTOA to figure out what numbers go on the top and bottom of each of your fractions here. Like this one. You simplify. Yep. Oh, look at you guys, you're simplifying and everything too. Oh, that makes me happy. All right. Let me catch up here. And if you got those, that makes me very happy. This is just a little bonus if you were able to simplify those. Get 4/5, 3/5, 4/3. That's awesome too. This is the main thing. If you were able to get that 8/10, 6/10, and 8/6, that's awesome. Now, some people may have had some of these flipped around. You might have had some other fractions there, and that's probably because the labeling. Okay, I'll tell you that the most common mistakes that people are going to make with this is they're going to label the triangles wrong. And once the triangle's labeled wrong, then your fractions are all going to be wrong too, right? So always double check those labels. Always double check those labels before you start making fractions. It's really easy to flip an opposite with adjacent, but that's going to make all the fractions. All right, so we have now learned how to label our sides. That's step one. We learned how to write equations. That's step two. Can you guys show me on your thumb meter how you're feeling about those two things? We're feeling pretty good? Fairly confident? Awesome, awesome. We're going to practice both of those things. If you'll flip the page over. This is the only other thing we're doing out of this packet today, guys. I'll work through a couple of these problems with you, and then I'll let you loose on it. As soon as you're done with this, you can start on the homework. All right, so let me run you through the first problem. So step one, always when we're dealing with trig, is we're going to label our sides. Okay. Now, eventually you're going to get to the point where like you don't need to label your sides, but you're still going to do it anyways because it's a smart idea. Okay. So go ahead and label your hypotenuse and your opposite and your adjacent. By the way, do you know what that symbol is? That little circle with a line drawn through it? It's a Greek letter. Anybody know how to say that letter? It is theta. That is the letter theta. You guys know your Greek letters? Absolutely not. No? Do you know what alpha looks like? Alpha looks like that. You know what beta looks like? Beta looks like that. Do you know what omega looks like? That's a lowercase omega, but uppercase omega looks like that. You might recognize that from a certain PlayStation NPO. Anyways, this is theta here. You'll see theta a lot. In trigonometry, we often use Greek letters to represent angles.
That is the symbol of our Greeks. Omega.
That's the, yeah.
It's also
the last letter of the Greek.
The symbol that
Alpha.
Uppercase alpha looks kind of like an A, I believe. There is some overlap between the Greek alphabet and our alphabet, which is the Arabic alphabet. Is that the Arabic alphabet? It's very different. Latin alphabet is the one we use. Then there's the Cyrillic alphabet, which is used in like Russian. And there's some overlap there too. Anyways. Okay, we got hypotenuse, opposite, and adjacent. Now, you know what? I should write my cheat code up at the top of the page. You guys remember the cheat code? You remember it without looking? It was what we were saying in our heads a second ago. So, Toa. Now, this one's specifically telling us to write a tangent equation. So I'm going to write tangent of theta equal to, and all I have to do to finish this is to make a fraction. So I got three numbers, 8, 15, and 17. I just got to know which one goes on the top, which one goes on the bottom. So this is tangent. So my cheat code's right here. Opposite over adjacent. Opposite over adjacent. So we want 8 over 15, and that's it. Make sure you're writing out the full equation. Don't just write over the 8 over 15. Write out the full equation. But that's it. We don't need to do sine or cosine for this because it asks us to do tangent. I'm going to do number 3 really quickly, and then the rest of them are under. Hypotenuse, opposite, they want to sine of theta equals, and all I need to do is fill out the number on the top and the bottom. Sine is, going back to my cheat code for my reminder, sine is opposite over hypotenuse. Opposite over hypotenuse, that's 5 over 13, and done. All right, let me get your attention for just a moment before you finish that all up. When you finish these problems, I'd like you to come up to the front board up here and check your answers. Okay, go our answers up here. The last 3 questions, I got a little fancy on simplifying them. So as long as you had the first step, I'm okay. Don't forget to simplify the last 3. And then when you finish this, your homework is on your stamp sheet. Go ahead and flip to your stamp sheet on the back of your packet. And look at this, man, I am making it so easy for you guys. You don't even have to write down your homework assignment anymore. It's right there. Our first one is going to be this lesson 1. The 7 problems looks like. Notice they're in 2 different chapters and 3 different sections. But you guys know how to find all that stuff by now, right? Today is the 31st, so this will be due on 2/2. Same as before, you'll get 10 points if it's complete on time, 7 points for completing it late. I'll give you 3 points if you got it on Thursday, and it's at least halfway done. All right. So the rest of the period is yours. I want you to finish up just this next page, okay? Don't worry about going further in the packet. The rest of the packet will be chipping off of basically 1 page every day as we go through our next picture. Questions? No, this is fine. Well, Right. Final result. Down the bottom. Yeah. Yeah, that's one of these extra ones. There. Can you put a number inside that? What's the radical? Square root. Yep. Square root is technically also. Yeah, we use this to figure out what they're doing. Opposite hypotenuse. I recommend always the hypotenuse. It's always the one across. Oh, thank you. Yeah. Okay. So let's walk through and make sure it's a label side for me. Where you want the hypotenuse for? Where's your ready? Where you what's the Yep, on opposite there. And then what's your that one step. So you're all right. Okay. That's sweet. So, and I'm gonna use the right on copy down the so oh, This is the best one. Yeah, it's- so, first letter goes with Then like, in your spot, then you turn it, that was the process. But you're always- Yeah, those are all good. Cool. There's a way to say, okay, that's fine. Let's leave it like, let's keep it simple. We'll talk about that. Later on. Look, we're gonna just- So I would actually just. Try. Yeah, so I can tell you what. We'll deal. You ready to go down? Good work on the whole, yeah. So you might be able to get done with half of the homework here while we're. Oh, there's books in the back of the well, books for one per table. I wouldn't even know. You bring up the. With that. Almost like I don't. What do you consider me? Just leave it just like, that's all. you do. Yep, you're gonna see it a couple more steps after this, people up there, but just. Yeah, so you can simplify this. Like, but I don't want you to worry. You can simplify this. I can look at this and probably, you know how to say that. It actually won't even be important to simplify it once we learn how to. So you're good to go. Your calculator will simplify though. Can I show you?
Yes.
Like, if you wanted to simplify 1250, you can type in 12, and then this will give you a fraction. We just use this, up this button here. Yep. They are, and they're in the. But if you, yeah. Give me just a second, I'll be right with you. Send this email to me. I'm just gonna put answers up on the board for the